Nanotechnology is a developing field of science related to the engineering of nano-sized particles composed of different materials. It has a very wide application in various industries such as construction by producing nanoconcrete. Nanoconcrete is concrete made with Portland cement particles that are less than 500 nanometers as a cementing agent. The addition of nanoparticles in concrete may improve its properties than conventional concrete. Nanomaterials such as nanosilica and nanocellulose have the capability to increase the durability of buildings by improving their mechanical and thermal properties. Usage of nanomaterials in concrete production can reduce energy consumption and manufacturing cost. However, some nano-sized materials may have harmful effects on the environment and human health due to their uncertainty and distortion in size, shape and chemical composition. Awareness of the possible beneficial impacts and the unintended danger of these nano-sized materials towards the environment needs to be enhanced when pursuing progress in the years to come. This study is carried out to identify the way to improve the properties of concrete with the addition of nanomaterials. It also brings proper attention to the probable effects of nanomaterial construction waste on environmental impacts.
Basically, the basic concept behind the nano modification of material is that engineering modification to the molecular structure with the aim is affecting the bulk properties of the material. This concept can be used to develop concrete from the bottom up to develop a new generation of concrete and cement materials. It is to improve the concrete technology that are needed now, which is the nanotechnology is a promising tool to accomplish this task. The introduction of nanotechnology to engineer concrete with superior properties promises that it is to deliver vast economies of scale through optimization of material behavior and performance needed to improve mechanical performance, volume change properties, durability, sustainability, and reduce calcination and carbon dioxide. For next slides, the following are the nanomaterials which are used in the concrete to improve the nanostructure. First, the material is carbon nanotubes, nanosilica, and polycarboxylates. Next, why is nano is created? It is to increase the strength and durability of concrete. It is to make sure that high workability with reduced water and cement ratio, which is to reduce the cost of making the concrete. Thirdly, use of super plasticizing additive that is unnecessary when making nano concrete. And lastly, to fill up all the micro pore and micro space.
Now, let's proceed with the summary properties of the nanoconcrete. The use of nanomaterial in concrete will give the better properties compared to normal concrete. The use of different nanomaterial mostly give the same effect on the properties of the nanoconcrete, but there are also slightly different that occur with the use of different nanomaterial. Based on the material that has been used, which is nanosilica, carbon nanotube, nano titanium oxide, and oxide nanoparticle, the properties of the nanoconcrete has been summarized as the nanomaterial have improved in terms of increase the compressive, flexural, and tensile strength, offer increased durability to the concrete, decrease the early and long-term shrinkage of concrete, decrease the total porosity of concrete, increase the abrasion resistance of concrete, decrease the required size of concrete structural members, and last restrict crack development and propagation at early age.
First step, the CNT, which is carbon nanotube combined with water. And for the next step, it will through the sonication process, and after that it will through the shear mixing process. The SPPL is a term of high mixing process. And lastly, it will disperse the solution. And then the solution will be mixing with the UHPVC concrete, and it will be casting, and lastly it will be demolding and curing, and the nano concrete finish.
Nanosilica is a nanomaterial used for construction applications that can substitute silica fume and microsilica fume. It was observed that nanosilica utilization in concrete enhanced the particle packing. The cement hydration rate also was improved, which efficiently improved the strength and lowered the dormant period and time of setting. This nanomaterial also decreased the concrete porosity and prevented the possibility of the degradation of concrete. Secondly, carbon nanotubes. Carbon nanotubes in a lab environment can be used to improve the strength of material and to contribute electrical conductivity. Carbon nanotubes are also added to the concrete as a nanofiller because they possess a higher surface area and unusual mechanical characteristic. Microstructural analysis showed that CNT filaments uniform dispersion inside the concrete hydration product in entire batches. CNT has incorporation in ultra-high performance with respect to mechanical properties and electromagnetic shielding effectiveness. The figures show the effect of CNT on the mechanical properties of ultra-high performance concrete. Lastly, ferric oxide. The optimum incorporation of ferric oxide nanoparticle in concrete specimens might increase the compressive strength. Addition of ferric oxide nanoparticles to the concrete could improve its mechanical properties such as its compressive strength. The hardened concrete's water absorption could also be improved with the inclusion of iron powder. Ferric oxide nanoparticle could increase the durability resistance of concrete against chloride as well as sulfate anion attacks. Figure below show scanning electron microscopy image of cementitious composite with 0%, 2%, 4%, and 6% of ferric oxide nanoparticles. For the discussion part, nanomaterials such as nanosilica carbon nanotubes have the capability for increasing the durability of buildings by improving mechanical and thermal properties, which could result in an indirect reduction in energy usage and total expenses in the concrete industry. Nanomaterial enhance the hydration process by generating more hydrated product. Various nanomaterial into the concrete mix decrease the setting time as well as workability. Lastly, the nanomaterial incorporated concrete could permit the development of ultra-strength concrete framework having a higher durability, thereby decreasing the maintenance needs.
Now, let me proceed with the conclusion. The study has offered complete and detailed analysis of improvement in concrete properties with the addition of nanomaterial. It risk evaluation, related health issues, and environmental implication of nanomaterial-based material for the application in concrete sector. The construction sector has a higher prospect of nanotechnology for solving certain complicated problems existing in this area. Lastly, Nanomaterial can offer concrete structure with self-sensing and self-cleaning abilities.